I need eyes and ears over here. The place I'm heading. Guys, if you are past that back set of desk over there, you are not where I asked you to be, in the center of the room, engaged in the learning process. If you are sitting, you are not as engaged as you need to be. Alright, so, first things first. I already started grading the test, and I need a lot of us to pay attention as I go over some key ideas to help you improve your understanding. Another thing that I want to point out is, Mike, head, thanks sir. Another thing I need to point out is I need y'all to pay attention to how to graph some things. Like some of us are doing well in identifying features and then not knowing how to graph. So I need us to pay attention to this as I go over these details. So, first things first. What form do we have of this quadratic? Factored form. Yes. However, and I'm going to carve out a little bit of space here to start with, we need to be careful and attentive to this. Our traditional factored form, doesn't it look like x minus r1 and x minus r2?
Yes.
Sure. So what's the issue here?
There's a 2x.
It's a 2x, right? Mm-hmm. If it's x minus 4, then yeah, we can just take the opposite for our roots like we've done in the past. That's not what we have here. This is why I pointed out and emphasized a really important detail that when we talk about factored form, we're also talking about the what? Zero product property. Notice when I use that 4 right here, f of 4, right? So notice what I'm substituting that 4 in for x. And I already talked about this, I know, but I want to re-emphasize this. What's 4 minus 4?
0.
0. So as soon as I multiply by 0, what is all of this going to become? 0. It doesn't matter what any of this is. 4 minus 4 is 0, and if I multiply by 0, what do I get? 0. That's a 0. That's why it's called a 0. The output is 0. Okay? That's my x-intercepts, my roots, all that fun stuff. And so if you check that 3 again, what's 2 times 3? 6. 6 minus 3 is 3. But what did I need? I needed a 0. Guys, the zero product property means that we are multiplying by a 0. So my output is 0. And we're making this way more complicated than it has to be. What is the only way to get a product of 0? Is if we multiply by 0. So either x minus 4 is equal to 0. Remember how we talked about the fact that I can just add 4?
Oh, you get negative 4 plus 4?
Notice that gives me the x equals 4 that we identified earlier.
Yeah.
So x minus 4 could equal 0, or what else could equal 0?
0.
Well, yeah, 0 does equal 0, but I'm talking about in this equation, what else could equal 0?
Negative 4 plus 4? That work?
Y'all, we already said x minus 4 could equal 0. What else could equal 0? 2x minus 3, right? There is a 1/2 here, but can a 1/2 equal 0? No. So 2x minus 3, though, could equal 0. I heard a group got here and then they're like, okay, what do I do now?
You divide.
I what? I would plus 3. What's negative 3 plus 3?
0.
Now, please hear me very clearly on this. This is not the only option, but it is, in my opinion, the most efficient and will always work. The way that I taught it, I think, with Maddie's class geometry a couple years ago was, and we didn't spend a ton of time on it because that's not what geometry is focused on, but what is happening to this x? Like, what's the first operation being applied? It's being multiplied, right?
Yes.
What's happening after we multiply by 2?
Subtraction.
We subtract by 3.
Yes.
You see how subtracting by 3 is the last thing there?
Yeah.
Think about it like an onion. Preston, make better decisions. Thank you. Do I need to collect that expo from you?
No.
Okay. Think about it like an onion. Do you just jump straight to the core of an onion, the inside?
No, you gotta cut it.
You gotta, well, or peel away the outer layers, right?
Outside.
Peel away those outer layers. What's my outer layer? What's the last thing being done? Minus 3, so I, well, what's the inverse of subtract? Add 3. So 2x is equal to 3. Remember, whatever I do to one side of the equation,
Gotta do it to the other side, man.
Did I talk yesterday about what that's called? What I
Yes.
do to one side, I do to the other?
It's called
Properties of equality,
equality. Yes.
right? I want you to notice, does 2x equal 3 look exactly the same as what we started with?
Yes.
It's got a lot of the same, but like, that's 2x minus 3 equals 0.
Yeah.
Does that look identical to this?
Yes. Without the zero.
Okay, so do they look identical?
Yeah.
You divide
no.
now, right?
Yes.
Fraternity.
You gotta divide by 3.
Well, hold on a second.
By
Over
two,
here,
by two.
guys. 2x minus 3 equals 0,
Yes.
and 2x equals 3. Are those literally the same?
No, they're fraternal.
Yeah.
They look different, but are they telling the same story?
Yeah.
Okay,
You gotta divide.
so they're what type of equations?
Equality.
Equivalent.
Equivalent. They look different, but they're telling the same story. They are equivalent equations because what I did to one side, I did to the other. Notice if this was a 0, would these be equivalent now?
No.
No.
No, they're not equivalent. So what I do to one side of the equation, I gotta do to the other to make sure they tell the same story. Now what do I need to do?
Divide by two.
Divide by 2.
That reciprocal.
We'll see some examples later why I use the reciprocal, but notice 1/2 times 2. What I do to one side, I gotta do to the other. 2 divided by 2 is 1. So x equals 3/2.
Yes.
Now, I'm going to take a second. I know there's a lot of work here, but that's the work to get there. I need y'all to pay attention to this. Sorry, I'm going to write a little bit over your stuff. 1/2 times 2 times 3/2 minus 3 times 3/2 minus 4. Okay. Hey guys, what's 2 divided by 2?
One.
0.
1.
Oh, 1.
1.
Great job. I'm sorry, bro.
What's 1 times 3? And what's 3 minus 3?
0.
0. So it doesn't even matter what this is,
Yes.
because what am I multiplying by? 0. Notice 3 did not work, but 3/2 did. You got to remember that 0 product property. The only way to have a product of 0 is if you are multiplying by a 0. What I'm seeing and hearing from a lot of us is we need to write out what the 0 product property means and an example of how to work it, right? We need to make sure that we understand the 0 product property. The only way to get a product of 0 is to multiply by 0.
Yes.
So set the factors equal to 0.
And don't forget that reciprocal.
That's it. Well, solve it, okay? All right. So, this are the basics that we would need. Now, I need y'all to pay attention to this. Literally, it says what equals 4. What equals 4? X. So guys, am I going to look at the x-axis or the y-axis?
8.
I'm going to look at x, aren't I?
Yeah.
Okay. So, how far am I going to go in the x?
4.
1,
four.
2, 3, 4. Notice, that's the point 4, comma 0. Hey, right here.
I'm sorry.
Because a lot of us are struggling on graphing. And guys, it's points. 4, comma 0. That's it. The x is 4, the y is 0. There it is on the graph. What's the other one now? 3/2, comma 0?
Yes, sir.
Hopefully you know what that is, but if you don't, you can use a calculator. 3 divided by 2 is 1.5. I would leave it as a fraction, but when
I
graphing,
did write it back. That's right.
I'm going to a 1.5, so 1 whole 0.5. There's my 2x intercepts. What else do I still need?
Yeah, vertex.
I need the vertex, but I mean like from last unit, I just need to know concavity, don't I?
Concave up and down.
So it'd be concave,
Okay. Up.
up, like a,
Cup.
cup. Hey guys, there's a whole lot of us that told me concave up and then drew it concave down like a frown. Y'all shouldn't laugh because a lot of us did that. Concave up is like a cup, concave down like a frown. Make sure you pay attention to that, okay? So concave up like a cup. Now, what other features could I find? We already said vertex.
Yes.
We'll talk about that in a second. But what's the easy one to find?
Concave.
Line of symmetry, I'm going to go there in a second. We already know concave up. I'm asking, what's a feature that we can find in every equation, honestly, pretty quickly?
The concavity.
Y-intercept.
The y-intercept.
Oh, yeah.
So remember, yes, we can, so A is a value and it tells us a feature. A is a value though. But my point is, a feature that we can always find pretty easily is the y-intercept. Because what do we know about every y-intercept that's ever existed? Right, my x or my input is 0. So f of 0, notice how I'm labeling my y-intercept here. F of 0 is equal to 1/2 times 2 times 0 minus 3
Lord, mercy.
times 0 minus 4.
That's a lot.
Dog, back up. You got a freaking calculator. Type that into the calculator if it feels like a lot. Like, I'm okay with calculator work.
Exactly.
Dang. I got a calculator.
So let's make up a calculator. Let's type that into the calculator and let's find our y-intercept.
That's what.
That right there? That right there? 2 times 0. You said type.
Ow.
F of 0. Everyone has a calculator in hand. I need y'all to type this into your calculator.
My calculator ain't working.
Then you better start using your brain.
F of 0.
Didn't know.
You don't know how to put them.
12
I'm not trying to be. I am fun.
He is fun. He is fun. Ain't gonna lie, doing this thing. The y-intercept, it's zeros and vertex.
Back up. No. The y-intercept is the easiest one to find. The input is 0.
Hold on, it's right here on my notes anyway.
So guys, right here, if you're
Oh, yes,
struggling on typing this in, because it looks like a few of us are, look at the screen up here. It's literally just 1 divided by 2
I got.
times 2 times 0
I got 0.
minus
I got
3.
12.
Then you need to check that again. 0 minus 4.
Okay.
Guys,
It's not defined.
you need to type this all the way in right here. Make sure you have that 1/2, Bakari, because it ain't 12.
I got a C.
Oh, I ain't got the 0 in there. That's fine.
You gotta have that 0 in there.
Give me a second.
Guys, so, who needs me to go back through and show you how to type that?
Yeah, I forgot my parentheses.
Make sure you have your parentheses, Mel, Yelvin, and Alexis. Anybody else need me to redo this up here so you can see it? Okay? Questions? You good, Cameron? Okay? Kel, you good with this? Deanna?
Got an error.
Okay?
Error.
Kamaya? Then you typed something in wrong, dog. You put a
It's 0.
You forgot the 0 right here.
You want Karen? It's Karen.
You're
People have no good.
running decimal instead of multiplication. Decimal multiplication.
I always say what
Okay,
God.
so notice right here, I now have the what? Y-intercept. Now, I'm going to go ahead and point this out. Listen, factored form, you really don't need to find the vertex or the line of symmetry much, and I'm not really going to assess you on it too much, except I do want to show this. We did talk about this yesterday. Where is the h in respect to my roots?
Oh, I can't tell.
Where is the h in respect to my roots? It's in the what? Remember, guys, line of symmetry, it's got to be in the middle. So what do I do to find the middle?
Somebody wrong with my drink.
I average them.
About 2.
So 3/2 plus 4 divided by 2.
Can we use 1.5?
Yes, but just use a calculator to find that average. It's going to be 2.75.
You crazy boy. Crazy.
So h is equal to 2.75. Okay? Notice this is a little spaced out differently, but does that look to be about the middle?
Nope.
Yes.
Bro, that's bro. So why you
But-
say no then, boy?
Right here, the reason why it doesn't look exact is because this part is smaller than these two pieces.
Yeah.
But that is the middle.
And that's why
Okay.
it didn't look like.
So we need to be precise with our graphs, but now I have some good information. The last thing I'm going to point out is this. How do I get K?
By looking at H.
Well, if I substitute H in, what do I get out?
K.
K. So what I need you to do now is use the calculator to substitute that 2.75 in. Now, I want y'all to look up here really quickly. I need everybody to practice this. So pause on the calculator and look.
Yes.
Remember, I can always hit the up arrow on the calculator until the expression is highlighted. I hit the enter button, and now I'm just going to change my inputs to that 2.75. That makes things really easy. So you just, so these are like computers. If you hit Control Z, it'll undo what you just did.
Wow. Why you took me?
I did.
You did?
Yeah, dog.
Is it time for me to go? Yeah, no. You sound like this dude on TikTok that he closed the window.
Hey, what's
So negative 1.56. So negative 1.6 or so. So, hey ladies and gentlemen, notice f of negative 5, was it, no, negative, or 2.75 equals negative 1.6 or so. So listen, come on, that ain't going to help you learn anything. That ain't going to help you learn anything. Listen, my point is this. If I substitute h in, what do I get out? Okay, that we're going to review these quadratics a good bit. Now, hey guys, couple of quick details. The real emphasis I need to point out is this. Zero product property. If you have a product of 0, so Alexis, pause for a second. I'll help you with the calculator in a second. If you have a product of 0, that can only happen if one of those factors is what? 0. So set your factors equal to 0. That's it. If you want a y-intercept, what do you already know? X is equal to 0. So substitute 0 into that equation for x. You can, listen, excuse me, you can memorize all the things in mathematics, except that sucks. Don't memorize all of it, understand it. Learn how to think about it and problem solve with it. Because if you understand a y-intercept, the x is equal to 0, that's going to work for every single function you ever study. If you understand that for a 0, the output is 0, that's going to work for every function you study. So learn to think with big ideas. Last really important idea here. I saw a whole lot of us do this on our test. Okay? I saw some people do this on the test. What's the issue?
Well, see,
It ain't a fun.
It's not symmetrical. I said it first.
So, I will say this. This is not symmetrical for sure. This is close enough to being symmetrical. That's not the problem I have. That is not what I was focusing on, but sometimes... Hey guys, I want you to think about this. Have you ever seen me draw a graph where the ends go straight up?
no.
One time.
They go out like that.
No, you sure that says that?
Notice, they go up and out a little bit because, is this even a function? Notice that one input has multiple outputs. That's not a function. Do not ever, ever, ever put that in behavior straight up and down. Don't you do it? Don't ever let it come inside and then go back out. That's a major misunderstanding of quadratics. Okay, so, what questions do you have before we get to today's lesson?
Actually, I think I got it. Yeah, I think I
Yes, just be aware, I
You show me how
have,
to say that.
but I might fail. Alright, hey, eyes and ears. We got to continue with this whole learning process. So remember, we started on the Tesla task yesterday. We're going to get more into it tonight. Put an extra detail in there to help. So, I need y'all to remember, I'm not here just to teach you math. Notice I said just to teach you math. There's a lot of beauty in mathematics. through mathematics, we can learn a lot of really important ideas, right, Jamie? So, pause on that. Listen, math has a lot of really cool properties, a lot of cool ideas. However, I understand, one, that some of us don't think we'll use math. I get that. However, the two people who told me today, hey, I'm going to do blank, so I don't need math, they sadly are mistaken because there are more careers that use math in small ways than you'd be aware of. Okay? On top of that, every job you go into, you got to know how to communicate with people, you got to know how to problem solve, you got to know how to have initiative. For those of us who are saying, oh, I have no clue what I'm doing, so my group's just not doing anything, that ain't it. I don't care who you are, you got to have initiative. No employer wants to hire someone who's just going to be like, I don't know what I'm doing, I'm chilling. That's not how the real world works. The real world expects you to do something and to figure it out. So let's do some stuff. Now, we have, yes sir. Okay, so where we stopped yesterday was looking at Teslas versus Toyotas. And I asked you to go to this tiny URL, and we should have done a little bit of research. Now, one thing I forgot to point out is this, and I had to update this on the fourth block. A Tesla has what kind of upfront cost?
Hold on, I can't see. Oh, 37,000.
So, Tesla costs almost $38,000 to buy it. A Toyota Camry costs almost
29,900.
And remember, we're trying to look at the cost of a Tesla. So, by the way, how many times are you going to pay those upfront costs? Dog, you paying for a car 3 times? Then you messed up. I ain't paying for a car 3 times. You outside your mind. How many times you pay that upfront cost? 1 time. I want you to think about that as you work with your group to figure out which one costs more.
I put a V8 in
My little Toyota cab.
I got it. Then, hey guys. And then we need to recognize that we go here, and we got these costs associated. Here's the cost of a Tesla. And I know it's pretty small. Let me make this bigger. Hey guys, the vehicle acquisition and depreciation, Caden, can you hit the light for me? How much is that Tesla costing every month?
$235 a month.
$235 a month. Is that cost happening one time?
Yes, it will be.
No, we haven't.
But it's happening every month, right? But every month,
I'm buying my
okay? Fuel and electricity. How much are you having to spend on that Tesla to go places?
25.
$25.30. How often is that happening?
monthly.
Monthly. Every month you're incurring how much more cost?
$25.
$25.30.
That's $0.
Bro. Oh my God.
Maintenance. How much is it costing to maintain that Tesla? $59.40. So is all of those things happening one time?
Yeah. No.
Every month you're incurring that cost. So I need you to work with your group on figuring out which of these vehicles cost more. Because you need to make an informed decision. So, okay, so, really quickly, we got to talk about a couple of things to get this moving forward. And guys, we got to get going using our brains a little bit quicker tomorrow because we're taking way too long on this problem. Right here, though. So, I want to point out, I don't know which group this is, but this group right here took that idea of the Tesla. And what did they do with that equation?
They multiply by 12.
Where did you see the 12?
Then they added by 6.
We equal it to 0.
They said it equal to what? 0. But guys, see, this is part of the reason why we struggle is because we don't listen when Mr. King's trying to teach things, and we play on our iPads when Mr. King's trying to teach things. We have our cell phones out in the middle of class while Mr. King's trying to teach things.
Crazy.
Hey, I do that.
Yeah, that's why I'm staring you down.
Get down.
Guys, if we're gonna substitute 0 in, what's that finding?
Zero pi property.
Well, not necessarily zero product property,
Oh,
but
it-
it's a zero or an x-intercept.
Yeah.
Do we need the x-intercepts for these?
No.
No, we definitely don't need the x-intercepts for these. But what do we need?
Why? Camry part
So, the Tesla cost,
and the Camry.
hold on. Well, so the Tesla cost is 319.7 x
Yes, Lord.
plus 37,990. The Camry cost,
The mic.
354.8 x.
Plus 29,000.
29,80. 87.0.
So guys, we already talked about this, that in the short run, which one's gonna cost more?
Camry.
Tesla in the short
In the short
run,
run, it's the
Tesla costs more.
Tesla.
In the long run, which one costs more?
The Camry.
The Camry.
Yes.
So what can I do with these equations to find where that changes?
5, 319, 7, and 328.
Add that, and divide it by
Hey,
8.
why don't we start thinking using our mathematical
See what I
representations?
did?
Tosh.
We can make a table.
We could do a
Okay,
table.
so we could make a table.
We could do it algebraic.
We could do it algebraically. Hold on to that idea.
Yes.
What else could we make?
Graph. I mean, the graph.
Could you make a graph now that you have some equations?
Yeah, and we talked about it.
So,
You can do
Hey, guys.
100, 200, 300.
We're gonna do a different strategy tomorrow, but I need eyes and ears on this
Yes.
because we gotta think through these things and not talk while Mr. Kinney's talking. 319.7 x plus 39,770. Okay, guys, just stay silent for 30 seconds while I type this in. Thanks. 354 point what?
My head.
8 x plus 29,870. Man, I don't see a single thing on this graph. That means I messed up, right?
No, you're gonna have to zoom out.
Okay, why would I have to zoom out?
Yeah, because that window ain't big enough.
I was saying, what's my y-intercept?
It's
38,000?
yes.
What's my maximum y right now? 6.67, right? So, what I go to do cool stuff? Menu.
And you go to graph engine. Graph
Hold
engine.
on.
Relation.
No, I gotta zoom out my window, but remember, I recommend window settings. I'm gonna go to like 100 months. I don't know if that's right, I'm just guessing. And then a Y max, let's go $50,000. Okay, so,
That's a linear, right? That's a linear line.
alright, so notice first off, are these linear?
Yeah.
I
Yes.
think so.
Can I tell when the Tesla becomes cheaper?
Both them.
No.
Not yet.
Oh, no.
So I need to change my
Open that
window
H.
again.
Yeah, open that.
Zoom out.
Alright, so I'm gonna go, let's go 100,000.
Is that little corn?
Alright, so still can't
Get in
see it.
Go to 100 feet down.
Well, so it's not the Y that's the problem now, it's the
I
X.
said change the A.
So let's change that to 150.
That's
Still getting closer.
200.
change to 250.
I'm gonna jump, I'm gonna go to 250.
Yeah, let's do 250. Okay.
Notice I'm trying to keep playing around with it. Oh my goodness. I was not prepared for this.
550.
I was not prepared.
550, 550, 550.
You put 7.
What is
What?
1E plus
Put
5?
7.
How did that happen?
What?
1E plus 5?
Oh,
Before
that's,
you get in this classroom.
that's right.
I'm not out.
Alright, I've almost got it.
Door open.
Woo! There it is. Can y'all see it? Do you see how right here in red, the red is my Camry,
Yeah.
which is cheaper. But after this point, that Camry becomes what?
Higher.
More expensive, more costly. So, I want y'all to pay attention to this. Where do I go to do cool stuff?
Menu.
Menu, okay, so where do I go now?
Table.
To find where they're intersecting.
You go to analyze
Let's try
graph.
analyzing that graph.
Yes.
Anyone see anything there?
0.
Zero.
Oh, intersection.
Are we trying to find a zero? We're trying to find a point of intersection.
Yeah, go to intersection. 4.
What is that asking for? A lower
Lower bound
bound,
and
so
upper
to the left
Left.
and then to the
Right.
right? So how long does it take for that Tesla to become cheaper?
What is 1299?
Don't worry about that right now.
Oh,
How many months is that?
282.
282 months. That's
About more than 3
that's 200 years?
Whoa, I'm gonna die by
Right?
buying a Camry.
No, 20 years. I'm way off.
Yeah, wait.
I was gonna say, buddy, why would I buy a Camry at that point?
So 10 years
Buy your own.
is 120 months, right? So that's over 20 years. So let me ask you this.
Bro,
Hey guys, are you, for cost, are you gonna go with the Tesla or are you gonna go with the Camry? I'm gonna go with the Camry, cost-wise, for sure.
And the looks wise.
And looks-wise.
I'm going
Now,
to paper
hey guys, you're asking about this E5, that's your scientific notation times 10 to the 5th, or 1, 2, 9, 9, 4, 1, 2, 3, 4. So after $129,000 of cost, the Camry becomes more expensive. That's 282 months later though. But here's the thing, and I need you to hold on to this for tomorrow. It was a pain in the butt trying to go through finding that point of intersection, wasn't
yes,
it?
bro.
But what do we notice about this cost? The cost is what? At this point of intersection, the cost is what? The same. Hey guys, what is this representing here? What's that representing?
Our Camry cost.
Our Camry cost. What's this representing? Tesla cost. And we need to know when those costs are the same, or when they are, no, what's the mathematical term for same? Oh, equivalent, not equivalent this time. Equal. Tomorrow, we're gonna do this algebraically to find when they are equal.
Why do you think?
Oh, you talking about?
It was 799.
Come in, hurry up.
My back,
Oh,
that's
you
your.
talking about?
Madison took it.
So that made it a little bit harder.
I mean, Addison.
It's part of the problem.
Where's my throwaway bag?
But thank y'all. Correct that, Mel.
Come on now, bro.
Why, Mr. King?
No, we didn't.
See you guys. Where's my other king? Why y'all stealing my cards?